All right, you all have heard of the electric force or the force of attraction or repulsion between two charges. Here's charge 1 and charge 2. They're attracting one another. You've also heard of the magnetic force or the force of attraction or repulsion between two poles of a magnet. Here's two north poles, and they're repelling one another. That's magnets. Now, they push and pull because they're surrounded by a field. Now, what's a field? You've seen it in comic books or maybe a movie where someone's surrounded by a force field. That's exactly what a field is in physics. A field is the area or region that surrounds an object, and each point in space around that object can be represented by a number or arrow that tells you something about that space. This is a gravitational field, and it tells you that the gravitational field can exert the force of gravity if you were to place something with mass or a moon in this field around it. And again, here's another picture. See these arrows? It tells you how strong the force of gravity would be on a mass if placed in that field. Now, here's an electric field, and it's around a negative charge, and this can exert an electric force that would be applied if a positive charge entered the picture. So if a proton kind of waddles in here, thunk, it's going to feel an electric force. Now, this is not an electric force here. This is a magnetic force, and you can see this magnet surrounded by all this iron. Well, if you're made of iron, you're going to respond to a magnetic force, and these iron filings will line up in this really cool pattern on the north and south poles of this magnet because of the magnetic field. So a magnetic field can exert a magnetic force on anything made of iron, like a compass needle. They can also exert a magnetic force on another magnet. So that's what a magnetic field is going to do, exert a magnetic force. Now here's the thing that changed the world. You got your magnet and you got your electron, and they're stationary. They don't interact, and that's sad, because we can't do anything with that. However, if you build a circuit and you turn that switch on and that electron starts to move, see there's that velocity there, it's starting to move, this magnet wakes up and something happens. This moving electron now, something special is happening because it's moving, and it just so happens that the magnet is now going to move. It's going to feel a magnetic force because of this electric electron. So that's kind of weird. You have this electric charge, which has an electric field around it, but now it's interacting with this magnet, and so there is a magnetic field being created. And that's the whole principle here. A moving electric charge creates a magnetic field. And that's pretty cool. So if you take a circuit, all you need is current. And you can move a compass needle or anything made of iron. So another bonus here is if you could turn your magnet on and off with a switch, or if you flip your batteries, you can actually change the direction, and that might be useful if you think about some devices that might use this principle. Devices that use this principle, they're called electromagnets, and they're all over the place. You can make a simple one. You could build a maglev train. Even your AirPods or speakers use the same technology. Fans or your Tesla Cybertruck or an MRI machine, they all use this idea. The idea that a moving electric charge creates a magnetic field. Think of how useful it is to move things that are made of iron. So if you have a current carrying wire, you get a magnetic field around it like that. If you loop that current carrying wire, you get a little bit stronger of a magnetic field. And if you loop it a bunch of times, look how strong that magnetic field is now. You've concentrated that magnetic field, so it's a lot stronger. If you get a loop like that, it's called a solenoid. Just remember that word. Now, every time you coil the current carrying wire, you concentrate the magnetic field, making it stronger. Remember, that's called a solenoid. And this is all based on the idea that a moving electric charge creates a magnetic field. And a magnetic field can exert a magnetic force. And a magnetic force, well, that can push or pull on a magnet or anything made of iron or even another electromagnet. So we have a simple electromagnet here. Why does it have this iron core here? Why the nail? Well, a nail, you got these iron atoms in it, and it just so happens that an iron atom, they are like little magnets. But in this case, most iron nails, they aren't magnetic because, well, their domains are not aligned. All these north and south little tiny magnets that a nail is made up of, they're all pointed in opposite directions and they actually cancel each other out. But if you introduce a magnetic field, like with your solenoid, then you magnetize that nail. Those domains are aligned and you actually greatly improve the strength of your electromagnet. So just remember that a moving electric charge creates a magnetic field, and then a magnetic field can exert a magnetic force, and that a magnetic force can push or pull on a magnet or anything made of iron or another electromagnet. And that's it. That's the idea of an electromagnet.